Okay, let's have a look here. You can run at a speed of okay, here. You can run at a speed of 6 miles per hour and and swim at 3 and are located on a shore 4 miles east of an island that is 1 mile north of the shore. How far should you run west to minimize the time needed to reach the island? So, in other words, so you start here, you run some distance x, and then you begin to swim. So the journey time, well, remember we have distance, speed, time, so that would be distance x over speed, which is 6, plus distance, which is root 1 plus 4 minus x squared over the swimming speed, which is 3. That's 4 minus x, and that's 1. So the derivative dt dx would be 1 over 6 plus, bring down the power, reduce the power by 1, and then multiply by the inside derivative, which would be 2, 4 minus x times minus 1, and that should equal 0, which means that should equal that. The 6's cancel, and we have root 1 plus 4 minus x squared equals 2, 4 minus x. So that would be root 17 minus 8x plus x squared equals 8 minus 2x. I'll square. So that's x squared minus 8x plus 17 equals 4x squared minus 32x plus 64, I think. So that's 3x squared, and then minus 24x, and then 64 minus 17 plus 47. Oh dear. Feel like I've done something wrong because I have 2 answers, and I don't know if that's right. So let's go. Let's you know what? Let's actually use the software to find our mistake, huh? Mm-hmm. 16, 17 minus 8x plus x squared. Yeah, that looks okay. 64, 4x squared minus 30. That looks right as well. Maybe it is correct, which I'm not so happy about. So that's x over 6 plus square root 1 plus 4 minus x squared over 3. Differentiate. Solve expression. Is that the answers I got? 4 and 3. Now, okay, so that is correct. Now, the answer, interestingly, is 3.42 on the software. So there must be a reason to reject the other answer, and it must have to do with this needing to be positive, perhaps. So we need. Oh no, that's going to be positive. Okay. That can't be 0. Oh, here. 8 minus 2x should be positive. So that means x should be less than 4. Otherwise, this equation, yeah, okay. Yeah, okay, that's Miles. Okay, that's a good question. That's a hard question, I think. It's a good question. Solving is a bit tricky. Okay. Okay, good. Good. How are we doing for time? Okay, that took longer than I thought. Okay, let's have a look at the next one here. Okay. For the following problems, consider a lifeguard at a circular pool with diameter 40. You must reach someone who is drowning on the exact opposite side of the pool at position C. The lifeguard swims at speed V and turns around the pool at speed 3V. Oh, okay, so like the lifeguard goes along here at V and then along here at 3V. And I guess the question is going to be, what angle should he depart at? Find a function. Okay. Find a function that measures the total amount of time taken to reach the drowning person. 327. Okay, the time would be this length. So remember, we have the distance, speed, time. So time is distance over speed. So it'll be that distance over the speed, which is v. And that distance there, well, we know the theta, and we know that this here, that's 20, that's 20, that's 20. So that there, that's theta. We can make a right angle here. So I could say that this length here is 20 cos theta. And there's 2 of them, so I think that'll be 40 cos theta. That's 20 cos and that's 20 sine. Yeah, and then now that distance there, that's the arc length, which is r times theta. Oh, no, that theta, it's not that theta, it's that theta. Oh, rats. I'll have to, okay. Okay. How can we get that angle? It's tricky. It'd be this angle. This angle. So if we call that alpha and that beta, beta would equal pi minus alpha. And alpha is pi minus alpha, and alpha is pi minus 2 theta. So that would just be 2 theta. So that would be 40 theta. Okay. I'm going to make this 120 and 3, so I can at least have it as all over 3v, 120 cos theta plus 40 theta. In fact, let's take 40 out, 40 over 3b. So that would be 3 cos theta plus theta. That's the time. And now we want to minimize the time. So the theta equals 0. That means that minus 3 sine theta plus 1 should equal 0. So that means theta is sine inverse 1 over 3. So that's about 0.3398 radians. Which is roughly 19.5 degrees. And we can confirm it's a maximum because this, the derivative again will be minus 3 cos theta, minimum, which is, if I put in now minus 3 cos 0.3398. Oh, that's negative. That's a maximum. So that's no. We wanted the second answer. Okay, so the second answer The second answer is pi minus the first answer. No, that's too big. Okay, 0.3398. Let's check the answer at the back. Huh? 327. Yeah, 40 cos theta over phi. 40 cos theta over 3v. Yeah. No. 40 theta over 3v. 40 theta over 3v. 40 cos theta over v. 40 cos theta over v. All right, well, that's the answer right for 327, which is good, but we don't have the answer for 328. Forty cos theta, I'll just write x for the moment, over 3v, over v, plus 40x over 3v. 40 cos theta over v plus 40 theta over 3v. Differentiate and solve expression. Yeah. Yeah. That was our second answer. That seems far too big and we can't go negative. It's got to be the smaller answer. Yeah. So then what's gone wrong now? Why is it not, let's differentiate again. Yeah, and then sub in 0.3398. It's a negative, which is a maximum time. We want a minimum time though. So why is that like that? We want the minimum time, not the maximum time. just put a value in for v, say 2, and then I'll just plot this. Theta is 0 we have this time. I'm just confused what I'm doing wrong here. Least amount of time. So the second derivative I would have thought should have been positive. And here I am with it being negative. That's really weird. That's really weird. Negative time doesn't make sense here. There's a limit to this formula. I don't know. I don't know. That's the time. I don't really care about this constant in the front. And the derivative is minus sine plus minus 3 sine plus 1. And the derivative again will be minus 3 cos. Weird. Which is negative, which makes it a maximum time. So what have I done wrong? Wrong. Hang on. Okay, let me just sub in a value, a bigger value for v to make it 5. Oh no, maybe it's too big. 1. Okay. And then let's plot that. Okay. 0 time doesn't make sense. So when does this formula stop making sense though? That's part of the problem. Theta has to be at most 90, which is pi over 2, which is about 1.5. So I feel like there's some issue with the sign here. Theta obviously has to be less than pi over 2 and more than 0. When the theta, no, the when the theta but I want this piece to disappear. At pi, I guess it could go to pi. Actually, it would need to go to pi, not pi over 2, sorry. And then, but that becomes minus 1. This length here shrinks as the theta grows. And this can only go down to 0. Yeah, no, it is pi over 2, sorry. Pi over 2, yeah. So pi over 2 is 1.5, so that would be there. but I get a negative answer. Why am I getting a negative answer? Oh, that's the sine formula. Did I type the formula in wrong? Oh, hang on. Okay, let's type this in again. 120 cos theta over 3v plus 40 theta over 3v. Okay, that's better. That's better. So yeah, we can see it's a maximum time. So I think this question is tricking us. I think we have to look at the boundaries. Interesting. Maybe this one is a max. So let's check it. Theta and time. And we have three situations. 0, 0.3398, and pi over 2. Okay, so if we put in 0, cos of 0 is 1. That's gone, and that's 1. So that's 120 over 3v. So that's 40 over v. And then when we put in 0.3398, so 120 cos that plus 40 times that. So that's going to be a little bit messy, but that is 42.2 over v, roughly. Ah, yeah. So it is a max then. And then the last one, pi over 2, 40 times pi divided by 2, divided by 3. It's 20 over 3. 20 over 3 pi. So that's the minimum time. The theta has to be pi over 2. Interesting question. And you can see it on the graph. When the theta is 0, we get this time here. And as we increase the theta, we increase the time. And if we keep increasing the theta, the time starts to come back down. But we kind of have to restrict ourselves to here. So this one here, yeah. Good question. It makes me wonder if I should double check the last one. Another great optimization question. I think this one's okay because I've seen this one a long time ago before and I don't remember anything weird about it. I've never seen this one before. And I like it. It's a good one here for tricking students into thinking that they found the minimum, and in fact, they've actually found the maximum. So the pi over 2 answer basically means that the swimmers should just go all the way around. Yeah. It's weird though. No, does pi over 2 correspond to... So theta is 0 just means go straight across. And then pi over 2 means to go all the way around. Why is that quicker than going straight across? The distance is more than pi multiple of this distance, but the speed is only 3 times faster. Oh, this is not, this is wrong. So if I put in 0, that's 120. Oh, no, it is 120 over 3. Yeah. 40 over V. I'm surprised by this fact. This is smaller. I'm really surprised by that. The time to go on the outside, that circumference, is 2 pi r. 2 times pi times r divided by 2 is 20 pi. Oh, hang on. Yeah, okay. So this here is 1.5 times longer than this, but he can go twice, or she can go twice as fast, or 3 times as fast. So although it's 1.5 times longer, the speed is 3 times greater, so the time is roughly halved. Well, it's just kind of rounding off crudely. Yeah, no, I get it now. I'm satisfied with my answer, and that's just another great question. So the answer is pi over 2.